assumptions for two sample unpaired or paired test for parametric or non-parametric data. Assumptions for Mann Whitney U test, which is unpaired non-parametric test. Assumptions for unpaired parametric student T test, and assumptions for Wilcoxon Signed Rank Test, which is a paired non-parametric test, and assumptions for paired parametric student T test, which is a dependent test. Assumptions for Mann Whitney U test, which is a non-parametric test, a test that is used when the data are not normally distributed. The Mann Whitney U test is also known as Wilcoxon Rank Test, is a non-parametric statistical test for data that lacks normal distribution. It is equivalent to the two sample independent T test. The difference is that the Mann Whitney U test only used for data that are non-parametric. So it is used to compare two independent groups, and it is used when the sample distribution are not normal. So when there are two groups and one of the group or two groups the data in it are not normally distributed, then the independent t-test cannot be used, and Mann Whitney U test is an alternative statistical test to use. So it is also used when the sample size is too small. So when to use the test? Use the test to compare two groups that are unrelated, not matched, unpaired, independent. Used when the data can be ordinal. Ordinal data is categorical data with order in it, such as the Likert scale, which is used in questionnaires and survey. Or the data are continuous, interval or ratio data but lacks normality. So it is used when the data are not normally distributed or skewed to the right or to the left. The test can be used when there are outliers. Outliers are extreme high or low scores or values that deviate from the rest of the data set. So to perform the test, hypotheses have to be generated. The null hypothesis will state that the distribution of the two groups are identical and the medians are equal. The alternative hypothesis will state that the distribution of the two groups differ. The way to accept or reject the null hypothesis is based on the p-value. If it is less than 0.05, then reject the null hypothesis. So what are assumptions? Assumptions are certain conditions that must be met prior to performing any statistical test to generate a valid and reliable result. Every statistical test have a set of assumptions. Violation of these assumptions, or if the one assumptions or more than one assumption is not met or are not met, then the Findings from the statistical test can be unreliable, which can lead to incorrect conclusion. So assumptions for the Mann Whitney U test are that the sample should be independent, separate, unpaired. The response variable, which is the dependent variable, is continuous but not normally distributed or ordinal. The two groups have similar shapes, distribution, form, and data are not normally distributed. So there are 6 major assumptions that have to be fulfilled before choosing to use Mann Whitney U test for the data set. The first assumption is that the data or the dependent variable can be continuous or ordinal. So the dependent variable measured at a continuous or ordinal level, continuous variables that are on numerical scales such as revision time, exam performance, weight. Ordinal variable is a categorical variable but with order in it, such as the 5-point Likert scale that is used in questionnaires and survey, in which the response from participant is given on a scale from 1 to 5, 1 for strongly disagree and 5 for strongly agree. So there is a category in the response and there is an order. So it's called ordinal variable or ordinal data. The second assumption is that independent variable consists of 2 categorical groups. So there should be 2 groups, 2 categorical groups. They are unpaired independent. Example: gender, male or female, employment status, employed, unemployed, smoking, is a smoker or non-smoker. The third assumption is the independence of observations. What does that mean? No associations between the observation or observations in each group of the independent variable or between groups. So different participants in each group. No participant participate in more than one group. So violation of the assumption, then you need to use the Wilcoxon Signed Rank Test for paired sample. The fourth assumption is that similar data distribution shapes. There should be same data shape distribution for both groups of the independent variable. The fifth assumption is random sampling. The sample is collected randomly from population and the samples represent the population. And the sixth assumption is that there is no need for the data to be normally distributed. Non-normal distribution, it means that the test does not require normality of the data. The test can be used when normality is violated. Assumptions for unpaired 2 samples t-test, or alternatively called independent t-test or unpaired t-test. Assumptions are certain criteria or conditions or characteristics of the data that have to be met before performing any specific statistical test. Each statistical test have a certain number of assumptions that have to be met before performing that specific statistical test. Violation of some of these assumptions can lead to invalid result or invalid interpretation of the data, or it can lead also incorrect conclusion. So before listing the assumptions for t-test, unpaired t-test, let's give a brief description of the student t-test. Student t-test is independent, unpaired two-sample t-test. It compares the means between two unrelated groups or unpaired groups. So there should be two variables. These two variables can be, one variable is independent variable, and this independent variable is categorical. It has only two groups in it. It is binomial, only two groups. Gender, such as the category of the gender, it can be either male or females, undergraduate or graduate. Those are two groups. The other variable is the dependent variable, and that dependent variable have to be continuous variables such as blood pressure, weight, height, and so on. So to perform the student t-test, you need two groups. These two groups have in it a continuous data. The two-sample t-test will determine if the two population means are equal or not. So the hypothesis will be generated, and the null hypothesis will state that the two population means are equal. Alternatively, the alternative hypothesis will state that the two population means are different, and then a p-value will be calculated, and the statistical analysis will be performed, and a value will be generated, and the null hypothesis will be rejected if the p-value is less than 0.05. So what are the assumptions for the test? There are 7 assumptions that are needed or required for unpaired t-test to produce a valid interpretation or analysis of the data. The first assumption is that the dependent variable have to be continuous. So the dependent variable is measured on a continuous scale that can be interval or ratio, such as revision time, exam marks, weight, height, salary, age, and so on. The second assumption states that the independent variable consists of two categorical groups, two separate groups, two independent categories. So the independent variable have two independent groups, such as the example of the gender, male or female, the employment status, employed or not employed, smoker, yes or no, and so on. The third assumptions for the t-test, unpaired t-test, is the independence of observation. What does that mean? That means that participants in one group differ from the second group. Basically, the participants in both groups are unrelated. So participants are assigned to one of the two groups and not to both. So participants are independent from each other within group or between groups. So the samples are unpaired. The fourth assumption is that no significant outliers. So what are outliers? Outliers are extreme low or high values or scores in the data that differ from the rest of the data. So how can we determine whether there is an outlier? By calculating the interquartile range, which is abbreviated as IQR, the z-score, the box plot. So this diagram shows a box plot to determine whether there is an outlier. outliers. The data are clustered between these boundaries or this range, the minimum range, the maximum range, and the line in the middle of the box is the median or the mean. And the star here is an outlier, which is an extreme score or value that is different from the rest of the data. So this graph box plot is a good tool to visually determine whether there is an outlier or not. The fifth assumption states that data are normally distributed. So the dependent variable is normally distributed in each group. To reiterate that both groups are normally distributed. So how can I check if the data are normally distributed? By plotting a histogram or box plot or QQ plot, or using several statistical tests that are available to check whether the data are normally distributed or not. The next graph here shows a histogram to visualize whether the data are normally distributed. And a curve is fitted into the data in a shape of a bell-shaped curve. The histogram will display whether the data are normally distributed or not. Another tool that can be used to determine whether the data are normally distributed or not is to use a box plot. And as shown here, if the two whiskers here are equal and the median is in the middle of the box, then the data most likely are normally distributed. Another way of checking normality when the sample size is less than 50 is to use a statistical test, such as Shapiro-Wilk test, to determine if the data are normally distributed or not. If the p-value is less than 0.05, then the data is not normally distributed. Here in this case, the data are normally distributed as the p-value is 0.2. Now, another way to check normality in addition to the histogram and box plot and statistical test is to use a QQ plot to check if the data is normally distributed. So draw a plot, and if the data points are aligned along the diagonal straight line, then the data is most likely are normally distributed. As shown here in this QQ plot, the diagonal line and this circle represent the scores or the value from each of the data. And all these small circles are aligned along the diagonal line, and this indicates that the data are normally distributed. If the assumption for normality is violated, then the t-test cannot be used, and an alternative test, which is the Mann Whitney U test, can be used. This test is non-parametric test that is equivalent to two sample t-tests. It doesn't require the assumption that the data is normally distributed. So if the data are not normally distributed, then this is the test to go for. Assumption 6 for unpaired t-test is that the homogeneity of the variances. What does the homogeneity of the variances means? It means that the two samples have equal variances. To determine if the variances for two independent or separate or unrelated or unpaired samples are equal, the first way is to use rule of thumb. If the ratio of the larger variance in one group to the smaller variance in the second group is less than 4, value of 4, then the variances are most likely equal. So then use the two-sample t-test. Let's give an example here. Let's say that in one group the variance is equal to 24.5 and the second variance for the second group is 15.2. So if we divide the variance 1 to variance 2, a ratio of 1.6 is generated. So it is less than 4. Then this suggests that the variances between the two groups are approximately equal. This is one of the way of rule of thumb to determine whether there is homogeneity of the variances. A second way is statistical method by using the Levene's test for homogeneity of variances. The test will assess if the variances across two groups are equal, which means homogeneity of variances, by generating two hypotheses. The first null hypothesis states that the variances of the two groups are equal. The other hypothesis, which is the alternative hypothesis, will state that the variances of the two groups are not equal. Then if the p-value is less than 0.05, reject the null hypothesis. If the assumption for homogeneity of variances is violated, then use another test, which is the Welch's t-test, which is a non-parametric version of the two-sample t-test and does not require or presume that the assumption of the homogeneity of variances. The last assumptions that have to be met prior to performing unpaired t-test is the random sampling, which means that the samples are obtained randomly from population. So those are the 7 most important assumptions that have to be met to perform student t-test, unpaired student t-test. Assumptions for Wilcoxon Signed Rank Test, which is a non-parametric paired test. The test is non-parametric statistical test that is used to compare two related or paired or matched samples or repeated measurements on a single sample to determine whether there is a population mean ranks difference. So it is an alternative test to the paired t-test, as this Wilcoxon Signed Rank Test is for paired samples. This test is non-parametric alternative to paired t-test when the data are not normally distributed and the assumption for the t-test is violated, which is the normality of the data. To perform the test, hypotheses will be generated. The null hypothesis will state that the median difference between the groups equal to 0, i.e. there is no difference between the paired samples. The alternative hypothesis will state that the median difference between the pairs is not equal to 0. To determine whether there is a significant difference or not, p-value will be calculated, and if it is less than 0.05, then the null hypothesis will be rejected. The advantages of using this paired non-parametric test is that it does not require normality of the data. So if the normality assumption is violated and the data are in two groups and those two groups are related or matched, then this Wilcoxon test will be the best to go for. The test is suitable for ordinal and continuous data that lacks normality. If the data are continuous and normal, then the paired t-test is the one to use. The test is also suitable to be used when there are outliers. Outliers are extreme high or low scores that deviate from the rest of the data set. The assumptions for the Wilcoxon Signed Rank Test are: the data should be paired, the data measured on continuous or ordinal scale, the distribution of the difference score is symmetric, the difference between the two groups are continuous, not discrete. Continuous means that it can have fraction in it. Discrete, there is no fraction, it is an integer number. The differences are mutually independent and the differences can be ranked, and the sample is randomly selected from population. Those are the major assumptions that have to be fulfilled prior to performing this non-parametric test. So there are 7 major assumptions for Wilcoxon Signed Rank Test that have to be fulfilled. The first assumption is that the dependent variable or data or the response or the outcome has to be continuous or ordinal. So the dependent variable is measured at an ordinal or continuous level. Ordinal variable is a variable that is categorical but with order in it, such as a 5-point Likert scale. Continuous variable with scores in it can be in a format of ratio or intervals. So ordinal variables are a variable with data that can be ranked, such as the Likert scale, which is frequently used in survey and questionnaire to obtain a response from participant. The scale can be from 5 points, Likert scale 7, and so on. And the response can be either strongly disagree or strongly agree, and so on. The continuous variable can be interval scale or ratio, such as revision time. For this test, the data has to be non-nominal. Cannot use categorical data for this test. Categorical data, a data that have categories in it, whether it is 2 categories, 3 categories, or 4 categories, as this test is not suitable for binary data or dichotomous data or nominal data. The second assumption is that the data should be non-parametric. So if it is a parametric data, then this test is not suitable, and that can lead to violation of the assumption for this test. So the data does not assume normal distribution. The difference between paired observation are not normally distributed. The third assumption is that there should be paired observations. The independent variable consists of 2 categorical, paired, related groups, or matched pairs. So it has to be 2 groups that are related, or a repeated measurement on the same sample. So measurement within the pair should be dependent, i.e. related, and each pair represent 2 measurements taken on the same subject or on matched subject. so that same subject are present in both groups. Example, those who participate in pre-test and post-test, same individual measured before the test and after the test. The fourth assumption is that the independence within pairs. So each pairs of observation are independent of each other, i.e. the outcome of one pair does not influence or affect the outcome of another. The fifth assumption is that the distribution differences is symmetrical. So the distribution of the differences between the two related groups is symmetrical in shape around the median, as here the median is taken as a parameter for estimation. Violation of this assumption, distribution of symmetry, then another test can be used, which is the sign test. The sixth assumption is the sample size. Small sample size can be used for this as it is a non-parametric test. So the test is suitable for a small sample size. And finally, the last major assumption is random sampling. Samples selected randomly from population, and the sample should represent population. Assumptions for dependent two-sample t-test, or alternatively known as paired t-test. Assumptions are specific or certain criteria or conditions about the data that have to be fulfilled before performing statistical tests. Each statistical test has a certain number of assumptions that have to be fulfilled. This has to be fulfilled prior to performing the test. Violation of these assumptions can lead to incorrect result, incorrect analysis, and invalid conclusion. So, paired t-test, or alternatively called dependent or related t-test, will compare the mean of two related groups. It will examine whether the mean difference between two paired observation is different from zero. So the hypothesis will be generated, and the null hypothesis will state that the mean difference between the paired observation is zero. The mean for the 1 minus mean 2 equal to 0. The alternative hypothesis will state that the mean difference is not equal to 0. Acceptance or rejection of the null hypothesis depends on the p-value. If the p-value is less than 0.05, then reject the null hypothesis. 7 assumptions have to be met prior to performing paired t-test. The first assumption is that the dependent variable is continuous. Dependent variable should be measured at an interval or ratio level. Dependent variable or variables can be a temperature. An example of the dependent variable are temperature, salary, revision time, reaction time, length. The second assumption is that the independent variable should consist of two categorical related groups. So the independent variable consists of two categorical groups, two related groups, two paired groups. An example is to take an individual and make a measurement before and after the treatment. So the same individual participates before and after the treatment. So that is a paired sample. The third assumption that has to be fulfilled is the normality of the differences. So the difference between the two paired groups are normally distributed. So you take the values from each group, subtract it from each other, and then check whether this data are normally distributed. The way to check normality is to draw a histogram, or to draw a QQ plot, or a box plot, or performing a statistical test, such as Shapiro-Wilk test, Kolmogorov-Smirnov test, and Anderson-Darling test, and other tests. So these are the visual presentation of the for checking the normality of the data: histogram, box plot, and QQ plot. So the for normality to be checked in drawing a histogram, the graph have to be normally distributed with a bell-shaped curve. And for the box plot, as shown here, this is the lower limit, the upper limit for the data, and the box in the middle with a line in it can be a median or the mean, and the length of the whisker should be equal. That's indicate normality of the data. And the third plot, which is QQ plot, shows the circle, blue circles here should be aligned on the diagonal line, and that indicates normality of the data. If the normality assumption is violated, then t-test or paired t-test should not be used. An alternative test is the Wilcoxon Signed Rank Test. This is an unparametric test which is equivalent to the paired sample t-test, but does not require the assumption that the differences between the two groups are normally distributed. So when the assumption is violated for normality, then this test can be used. A fourth assumption is that there should be no significant outliers. So what are the outliers? Outliers are extreme, low, or high scores that is different from the rest of the data. As shown here in this box plot, this star here with 1 is a very low score compared to the rest of the data, as they are all clustered in this diagram. Here also in the right hand side box plot, extreme high value from the rest of the data is shown here. Another assumption that have to be met is the independence of pairs. So each pair of observation should be independent of each other. So the outcome of one pair should not influence the outcome of another pair. The sixth assumption is that paired dependent observation. Data consists of pairs of related observation. So the measurement is taken or done on the same subject, such as before and after treatment for the same person, or different measurement from the same subject. And finally, the last assumption that have to be fulfilled is the random sampling, which means that the participants should be randomly allocated or selected or picked from population. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others, so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, Statistics, GraphPad, Prism, GPower, Python, and Mann. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, Statistics, GraphPad, Prism, Mann, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.